to continue with cloud computing. So today we're going to talk about FusionCompute virtualization features. So the features of FusionCompute virtualization. That's what we're going to discuss today. If you missed the last lesson, please check the previous video. Then you can take it from there. Second, I'm just trying to make sure I am showing the right file. So, so on the so we have as FusionCompute virtualization features. We have an online CPU and memory adjustment. So online CPU and memory adjustment. So what we can notice is that FusionCompute dynamically adjusts compute resources for running virtual machine to improve the flexibility and just service continuity. So basically, there's no interruption between different processes. So just 1 second, guys. Just trying to get the right. Reading the wrong. All right, so the online CPU and memory adjustment. So we're going to have different technical principles, such as your virtual RAM and virtual CPUs that can be added offline or online and deleted offline as well. So we have the virtual machine states, which can be online. That means it's running, or offline, which means that it's shut down. So we will have certain what you call this, the technical features that we can have in this case, like the CPU and the memory specification, that can be adjusted when the virtual machines are running. That means that the virtual machine is online, right? So this can help us minimize service interruptions. So CPU changes on running virtual machines can take effect only after the virtual machine is restarted. So need to understand that the adjustment that we can do on the virtual machine cannot be done without restarting the virtual machine. So, and then we have a scenario that can be there is it applies to services that require flexible adjustment to the number of CPUs and memory size of virtual machines, right? So we can have a FusionCompute which can provide flexible input-output resource configuration, for example, where we can add or delete the network interface card. We can have them online or offline. So this is a few features that we can have. So some of the benefits of using this method, this feature is the fact that we're going to have a minimum user service interruption. We have efficient resource utilization and scaling, Okay, so everything is just simplified. All right. So the next feature will be the CPU QoS, right? So this feature will just allow the administrator to set kind of an upper limit of resources such as CPUs, memories, network, and IOPs available to the virtual machine. So what this means, it means that when you have FusionCompute operating system, this will provide your CPU QoS mechanism to just ensure that there's a fair and efficient CPU resource allocation among virtual machines. So you have your CPU QoS that can enable guaranteed performance for critical workload. We have optimized resource competition, which is based on the of um, of of the priority that we have. So we can maximize physical CPU utilization as well for cost efficiency. So what you need to understand there is that CPU resources are allocated on demand with priority control and resource reservation, right? Which can ensure that we have a consistent service performance even under heavy load. All right. So that's what this CPU QoS helps with. Okay, so it can help like in terms of different parameters such as the CPU quota. So how much of the CPU can be used by um, a certain virtual machine, right? So if this CPU is being used by multiple virtual machines, so how do we ensure fairness and weighted competition? How do we ensure that different virtual machines are using certain amount of the CPU? So if the CPU can't be used maybe at 50% by one virtual machine while you have maybe 10 virtual machines. So to ensure that we have the CPU QoS parameter that can set the limit, the upper limit for resources. So it sets the limit, define the maximum CPU that a virtual machine can use, right? So this will prevent all the excessive resource occupation by other virtual machine. You understand? So that's what it means. So okay, so the QoS will make sure that we have a stable performance of the whole system, okay, and we can easily control how much of the CPU is being used. All right. So, and then another feature that we have is the VM resource management, which is an host memory over commitment. All right. So, this feature will just allow the server to provide virtual memory that can be larger than the server's physical memory. So, we can have a server that has at a certain capacity, but we can, if we need more of that, instead of buying the physical server, we can actually have a virtual memory which is bigger than the physical server that we have. All right. So that is one of the that's the role of this feature here, right? So you need to understand that FusionCompute will support memory over commitment, which will allow the total allocated virtual machine memory to exceed the physical memory of the host. So this feature will just, I can say, boost resource utilization or reduce hardware costs. And so instead of you buying more hardware, we can just increase this virtually. All right. So when a memory over commitment is enabled, the following three technologies will be activated. So we're going to have memory sharing, memory swapping, and memory ballooning. All right. So these three technologies are the ones that are activated when memory over commitment is enabled. So if on your FusionCompute software you enable the memory over commitment feature, these technologies are activated. So basically, you have your memory ballooning, which will automatically reclaim and use memory from virtual virtual machines, right? So if a certain virtual machine is not using a certain memory, it's going to claim it so that it can be allocated. So you have a relocated memory becomes available to other virtual machines. So we can reclaim and use memory from a certain virtual machine, which can be used by another virtual machine. So in memory ballooning, you need to note that applications inside the virtual machines are unaware of the ballooning process. So the application do not know that memory is being borrowed from other places, but this is what the system is doing, right? So this will ensure physical memory is efficient shared across the whole workload. All right, so this will just help us just to maintain the performance without unnecessary swapping, all right? And then the second technology will be the memory swapping. So the memory swapping or swap volume, so this one will just treat external storage such as your disk. It's gonna treat this disk as external memory. All right, so memory swapping is similar to what we always do when we're trying to use a computer. We don't have enough space. We can have an external hard drive. So this is similar to that. So with virtual machines, we can actually have an external storage such as the disk, and we use it as an extended memory, right? So um, so with memory swapping, the process, what the process does here, uh, the memory data not currently in use is swapped and mapped to the disk. So what does it mean? It means that any inactive memory pages are stored temporarily to the disk, right? So when needed again, then the pages are swapped back into physical memory. So this will improve your memory capacity, but may also impact the performance under high swapping. If there is a lot of swapping happening, this can affect the whole performance of the system. All right. So the last one will be the memory sharing. Right. So we have different virtual machines here. We have VM1, VM2, VM3, and then we have a physical memory. So in memory sharing, that means that we identify identical memory pages across virtual machines, and we store only one copy of the duplicate pages. So if virtual machines have certain pages that are similar, instead of saving all of them and taking more space, we're just going to store one copy of these duplicate pages. So that's what memory sharing does. All right. Um, so particularly, this is effective in environments where your virtual machine can run similar operating system or apps, right? It's going to be very difficult if on one virtual machine you're using Windows, on another one you're using Linux. So there may be a problem there. So it works well when virtual machines are using a similar operating system or similar apps. All right. So we need to note that. All right. So the next feature is going to be the. So the next feature is going to be the live migration. So the virtual machine live migration. So this feature will just allow the virtual machine to be live from one server to be live migrated from one server to another without interrupting the service. So sometimes for some reason you want to change the server. You want to move from one server to another server, right? So so how do we make sure that we can move from one server to another server without having to interrupt the service? All right. So if today you have a company such as Facebook, you don't want Facebook to go offline when they want to move from one server to another server. You don't want to know that they are doing that. So these are certain things that are needed. So this feature of FusionCompute, the VM live migration, is a zero downtime workload mobility. So this is to just enable a running virtual machine to be moved from one physical host to another without interrupting the services or disconnecting the users. So there will be no interruption to virtual machine services or network sessions. You have your memory data that are preserved, right? But they are also synchronized to the new, what you call the new server. So this will just ensure that all the services, we have a certain continuity during the back-end maintenance, for example. So when we have this feature that is going to help us in terms of migration, right? So when live migration is used, we can avoid service downtime. So this can happen sometimes in planned maintenance. You know, when we have certain maintenance of the system, so we can create we can use this feature. So if the system is being maintained, yeah, we can have this feature. All right. So and then the next feature of FusionCompute will be the VMHA. So when we talk about VMHA, this this feature, right, will just ensure that virtual machine can automatically recover from failures, right? So if we have any failure on a virtual machine, we need to automatically recover from failure without having a downtime or having a system being um, interrupted or affecting the user. All right. So because the application that we are using or the system can be running critical services and we don't want to interrupt anything. All right. So we need to have a way of detecting these failures of the virtual machine and addressing these errors without interrupting the system. Right. So the feature that can do that can ensure that we have a quick recovery of the virtual machine is the VMHA. So that's the main purpose of this feature. All right. So the next feature, will be when we talk about rule groups. Rule group. So when we talk about a rule group, we have a few. How can I say it? So basically, rule group will just allow the administrator of the system, to be able to control how virtual machines are distributed. All right, so we can control how virtual machines are distributed, right? We can create different clusters of virtual machines. So the rule groups are used to meet different application deployment and different availability. Sometimes it's going to depend on what you want to do. So in a certain organization, you have such a big organization, but you don't just want to place virtual machine like that, but you place virtual machine based on a certain purpose. So that's why you're following the rule group. So rule group in Fusion, what you call this FusionCompute, so you can set up how you want to put that to make sure that you meet different requirements, such as keeping the virtual machines together. So when we talk about virtual machine, so virtual machine in a rule group must run on the same host. So if we have virtual machine like this one, they are under the same rule group. That means they have to use the same host. So we ensure that selected virtual machine run together on the same host. So that is to keep the virtual machine together. So so this is, for example, you are using an application that requires certain communication, and you realize that the communication with the application are only done by certain virtual machines. So you want them to actually work together. Only those machines can use that host, right? So that can help increase certain performance. For example, if you have a certain group of virtual machines that are using one host, so that if there's a problem with that host, only those virtual machines are affected. And if those virtual machines are only using one application or a certain software, it's only that software that will be affected. Instead of having multiple systems, but they are using multiple virtual machines in different hosts. So once there's a problem, everything is affected, right? So the second will be to keep virtual machine mutually exclusive, right? So if VMs in a root group that are following this method, it means that they must run on different hosts. So with this method, we will just ensure that the selected virtual machine run on different hosts. All right. And then the third one will be VMs to host. So VM to host means that we have a VM host affinity, as we can call it. So the VM group must run on the host group. So this one will bind a VM group to a specific host group. So this will ensure that all the VMs start only on approved hosts. Okay. So this can be used in cases of licensing restrictions, for example, where there's a certain license. So if a person has a certain license, for that license, certain virtual machine can only run on a certain group because they are licensed on a certain level. Okay, so that will be the rule group. Okay, so we have dynamic resource scheduling. So when we talk about dynamic resource scheduling, so in FusionCompute, dynamic resource scheduling will use intelligent algorithm just to automatically optimize the resource distribution in compute clusters. So this will help in terms of the load balancing. Maybe the CPU need to use a certain amount, maybe 80% of the memory is being used by the CPU is used by 80%, the memory by 80%. So a certain virtual machine need to use a certain capacity. So in terms of to achieve all the load balancing and higher performance and reduce power consumption, so the dynamic resource scheduling will actually have to come on board to just try and make sure there's no service interruption anyway. So it's going to control how the CPU is being used, the memory usage, virtual machine workloads, clusters, resource conditions. So those are certain features of this. All right. So and then we also have a dynamic power management. So in this case, the dynamic power management will just make sure that it helps optimize all the cluster energy efficiency, right? By just adjusting the numbers of active hosts based on the workload. So based on the workload, the dynamic power management will just help adjusting the numbers of active hosts. All right, so it's going to, like, some of the time it's going to check the CPU, the memory, and the overall resource usage across all the clusters. So if resources are insufficient, but the host load is light, for example, so this will kind of migrate certain VMs to fewer hosts, and to just try and save energy. So that's what the dynamic power management does. All right. So and then we're going to have the CPU pass through and GPU virtualization. So can anybody tell us what the difference between a CPU and a GPU?
A CPU is a central processing unit, while a GPU is a graphical processing unit.
Yeah, so the CPU will actually deal with operation of software, just simple um, control of how softwares are operating, but the GPU will be more involved into everything that has to do with graphics, all the graphics, all the calculations, like matrix calculation, especially when you are dealing with tools that have AI capabilities. The CPU is overused, right? So when we talk about GPU pass-through and GPU virtualization in FusionCompute, so FusionCompute will support high performance GPU uh, capabilities for virtual machine. So this will provide kind of a flexibilities for graphics. When we have high intensive graphics, or computations workloads that we can have in virtual machines. So the GPU pass through will allow the physical GPU on the host to be directly assigned to a specific virtual machine when those operations are happening, right? So this will provide kind of a GPU performance for the virtual machine to help that virtual machine can have a high performance graphics, video processing, or certain computation of and some AI workload. All right, so that's very important to note there. So um, so in this case, you need to understand that only the virtual machines that has been assigned can access the GPU. Okay, so this is ideals for VMs that are requiring exclusive GPU accesses. Okay, so this will just ensure that we have a maximum performance. All right, so you need to understand that this GPU cannot be shared amongst multiple VMs. So it's specifically accessed by the VM that is has been assigned to that. All right. So when we talk about GPU virtualization, GPU virtualization, so we have an example of uh, of the Intel vGPU, right? So this is basically physical GPUs that can be virtualized into multiple virtual GPUs. So the virtual GPUs are called the vGPUs. So this is when um, physical GPUs are virtualized into multiple virtual GPUs, right? Um, so this can be done just for it to be used by multiple VMs. Okay, so so now in this case, if we're using it on multiple VMs, because remember now when we had the GPU pass through, it means that in this case it's only one VM that can get access at a time. But now we can take those um, GPU drivers, those GPU, we can take those physical GPU, and we have one physical GPU, and we can actually virtualize it into multiple virtual GPUs. So now when we multiply it into multiple, we virtualize it into multiple GPUs called vGPUs. This can means that we can now use it on multiple VMs, not just one VM. So now when we're using it on multiple VMs, it means that now each VMs will receive a vGPU instance, right? So each VM will have to use a certain instance. So for example, a certain VM is requiring a 2D graphic acceleration. Another one is requiring a 3D graphics rendering or something like that. All right, so some key benefits of that is we're going to have a high graphic performance, at a very low cost. So we don't really need to buy physical GPUs. We can actually take one GPU and create virtual GPUs for this purpose. Right, so we also have a concept related to storage virtualization. So when we talk about concept related to virtualization, so storage virtualization in FusionCompute really abstracts physical storage devices into data stores, and then that will help us provide kind of a unified or logical view of storage resources. All right. So this in this virtualization, we have certain concepts such as the data store. So when we talk about the data store, we are talking about a logical container, which is similar to a file system, right? So virtual machines are stored as group of files, right, within a certain data store directory, right? So so the data store will actually hide the differences between storage devices and then providing a just consistent interface for virtual machine. The main purpose of storage virtualization will be to just simplify the management of storage resources, to just enhance the flexibility in storage to virtual machines, right? And then it's just gonna improve the whole storage utilization, right? So this is very important to know that the storage virtualization will allow that the administrator of the system can just focus on virtual machine management without worrying about a specific storage hardware. You know, we don't have to worry about certain hardware and whatever, but we have the virtualized part of it. All right, uh, so certain so this is what we have. So these are the storage concept of Fusion concept. So we can have uh, certain resources such as the local disk of the host, and then we have certain dedicated storage, certain storage devices, right? Um, so these dedicated storage devices that are just connected to the host via a network cable or fiber. So that can be external storage. We have our local disk on the host that can be directly used as resources for virtual machines. We have data store. Okay, so basically the data store will just be the logical containers that are created from storage resources. All right, so yeah, okay, so those are certain elements of the storage utilization. So we have a certain architecture of that of the storage virtualization in FusionCompute. So when we're looking at this architecture here, we have, for example, different user of virtual machine with front-end drive, right? So these virtual machines are actually getting memory either from the local storage or from an external storage through certain cables. So basically, so we will actually have certain components such as the block devices, right? So those block devices, which will include things such as the SAN devices, we have the NAS devices, or the local disk. All right. So it means that we have the system, we have the virtual machine connected to the host through a certain network or local interface, right? And then we can easily manage the block devices, which can present just a storage view of the host. So this is how we can be able to manage the whole system here, where we have we can have certain disk driver layers, right? Which means we attach certain virtual disk to the virtual machine only when needed. And then we have virtual machine disk input output, which is managed through systems such as QEMU. Okay, so QEMU will be just a front end driver, um, which will receive all the requests, such as the read, write, request, and then QEMU will process this request, right? Uh, which will be the request now will go, let's say in this case we have maybe an image file which will go through the file system, and we can take it from there, right? So these are some of the tools. So basically the way the workflow will work is that we have the virtual machines here through the front end drive that are making a certain request, and the request go through the QEMU interface, and from the QEMU interface we go through the disk drivers, and then we go through the physical storage. All right. So the way we have data store, we have data store usage. So when we talk about data store usage, what we actually mean is how we, after virtualization, so we have data store that can be virtualized, and then we can create a common disk on a virtual data store that can take a long time, right? But we can the virtualized data store support some advanced features such as creating thin provisional disk, right? So we can have what we call an RDM, right? An RDM, which is a raw device mapping. So a raw device mapping, which means that we can have an RDM data store usage. So in this case, the data store can be used as the entire disk for the RDM. So only the disk that are matching the exact capacity of the data store can be created. So so in this case now, it's gonna help us in situation where we have like a live migration or things like that. So we will have things like a disk allocation where we decide what the disk size. The disk size must obviously be equal to the disk data store size. All right, that's one of the most important things. So you need to understand the RDM. The RDM will actually allow a virtual machine to access storage directly at the data store level. Okay. All right. So about the storage model in FusionCompute. So in FusionCompute, we have a certain uh, storage model. So basically, FusionCompute will just provide flexible storage models, which is depending on certain storage type and the requirements. You understand? So the storage type and the requirement. Remember here, the storage type, we say we can have data store, which means we have a shared directory with a file system and logical volume. We have storage devices or storage resources, especially online. So when we have things like local hard drives, so when adding a data store on local drives, you can choose the virtualization mode, for example, from FusionCompute. So from FusionCompute, you can choose the virtualization mode, which means that this mode will just take the physical storage into data store, so which will enable all the advanced features such as snapshot, live or cold migration, link clone, cloning all your data there, right? And then we can have a SAN storage, which means that if we're adding a data store uh, to SAN storage, you can select between the virtualization mode or the RDM, which is the raw device mapping. All right. Okay. Or we can also use the Huawei distributed block storage. So the Huawei distributed block storage. So when we're adding the storage to the Huawei distributed storage or Huawei DBS, the system will use a non-virtualized mode by default. But in this case, we need to understand it's just providing a high performance storage, which can be suitable for certain enterprises, especially enterprises that are involved in telecom. All right. So we've just note that with the storage model in computer fusion, right? Local disk supports the mode of supports the virtualization mode. Okay, the SAN can also support the virtualization mode and RDM, and the Huawei DBS only support the non-virtualized mode. All right. So the next one will be the Vim. Okay, so this is just a table that is showing all the data storage association model, the relationship between your storage device, storage resources, and data store. So as I've said, I've mentioned here, this will support the virtualized mode. The SAN device will also support the virtualized, but when we have the Huawei, um, so this one is non-virtualized. So it's in terms of the data store, it's gonna support the Huawei distributed block storage. All right. So we have another feature of this FusionCompute will be the Vim virtual cluster storage file system. So Vim stands for Virtual Image Management, right? So this is Vim. So Vim will stand for that. So the Virtual Image Management system is just a high performance cluster file system, which is just designed for managing virtual machine storage in your FusionCompute. All right. So we have certain storage files, so not storage file, but certain format of of, of saving these data. So what Vim is going to do is just it's going to enable the application of the virtualization technology to exceed the limit of a single storage system, which will enable multiple virtual machines to access a clustered storage pool, which will improve resource utilization. So the Vim, as basis of virtualizing multiple storage servers, provides services such as live migration, dynamic resource scheduling, and a high availability for storage devices. So we have multiple virtual machines that are built through the FusionCompute software. Through Vim, we can have access to different type of storage. So you need to note when we have Vim, so it's basically a high performance file system management for just storing virtual machines. Okay, so so in terms of certain capabilities of VIMs, we obviously understand we're going to have a high performance because of this feature, because it accelerates the whole operations in terms of writing or reading anything from the virtual machines, right? So so understand that VIMs will just provide a unified and high performance and flexible file system for FusionCompute, right? So this will just make easier the management of virtual machine disk, right? All right, so that is Vim. So we can have what we call a Vim distributed lock. So Vim distributed lock will be you have your Vim's volume that are mounted to a multiple CNA node at the same time. So which means that each CNA node can access files on the Vim's volume, right? So yeah. All right. So this is what we call the Vim outbit. So we have two type of outbit. So we can have the network outbit or the disk outbit. So the disk outbit is used to just check whether the host can read or write the shared storage, right? And the network outbit is used to check whether the network communication between hosts is normal. All right, so that's all. All right, guys, that would be all for this session. Um, yes, I will see you in the next session at 6:45.